Hello guys and welcome back to the channel. So we've actually completed the first part of this tutorial series, which was really basically about covering all the topics which we have defined up here. And now the last part, or more or less the second part of the series, would be us building this applications. And what's part of what we've done until now, apart from just working, like giving us a walkthrough through Rust, we've also in the process actually ended up building a backend application. And of course, a more or less a robust server. We try to cover most of the things you would probably need if you're building like a production grade backend server. And most of that, of course, you can always go back to the series, can start from the beginning or whatever it is you feel you have to start from to, of course, bring you up to speed what we've covered until now. And of course, on top of that, we've also gone through building serverless functions in Rust. So in the last series, I also shared with you, of course, a video which I already did, which was about building serverless functions with Azure and, of course, on the AWS cloud as well. And so now what I would like us to really do first, if you look at the list we have over here, would be to build a chat server. So I'm just gonna mark this one out because I think this would be more or less the first straightforward thing I would like us to do, given that we can actually embed this in our current backend server. Most of the other things we have here, we might have to, of course, build out a complete standalone application. So that's why I'm embedding this in this one. So anyways, let's jump right in and get started. So I can take you right to the main function. There's nothing changed here. So if you look here, this is more or less what we've done until now, covering like all the topics we did in the development of a backend application. But the only new thing now, of course, that I have added to make it, of course, easier, because I don't want us to spend so much time talking about the things I feel you already should know at this point if you followed through this series. And but what I've added is that I've gone here to add two simple endpoints. These are more or less WebSocket endpoints. And again, I'm going to take my time to, of course, explain to you in details what's actually done here. I'm probably just going to collapse this one because you don't need it anymore. But if you look here, you would actually see that we have two endpoints, one going at /v1 and the other one, of course, at v2. And if we go to the definition of our endpoints, there is this chart here under API, and then you can see all of these two services actually scoped to the endpoint WS. So what it means is that if we come here, this would be served at /ws/v1, and of course v2 would be for the subsequent one. So to show you what we have until now, I'm just gonna take you to the browser, and then we can just take a quick look. So here on the browser, as you can see, I've pasted this endpoint here. And now when I try to connect, of course, we don't have the server running, so I have to start it 1 second. Cargo run. And now this server should be up in a minute. And now the server is up, but we still seem to have this cron part running. So what I can do, of course, I don't want it to clutter our space because I want us to see exactly what's going on. So I'm just going to stop this one more time, then go back to main. And I'm going to take this whole part out. We don't need it for now. And I think this one as well. And maybe also the scheduler, but I think that's already fine. So let's restart the server and then we can go ahead and do the testing we want to do, because I want to show you what we have at the moment. So maybe I'm going to give more room here so you can see what's going on. Now the server is up one more time. Of course, if you might have seen this error over here, but I expect you to know why we have this error. If you don't, please go back and look at when we talked about working with NAT's server, and of course how we integrated this into our Rust backend. So again, I'm just going to take you back to the browser and pull up this page, and then we try to connect one more time. And let me see. Yes, I think we still have, I can also show you. So let's come here. So we have this middleware, this auth middleware. So this is of course blocking every request actually. So I'm just going to take this out for now and restart this server one more time. Actually, I'm just going to do it this way: cargo watch, execute, run. So that way I don't have to restart the server with every new change I make. So, so it's up one more time, and let's test again. Let me clear the screen, try to connect. And now you actually see we are able to make a connection. Of course, I can also try to connect from this client, and it's also able to connect. And I can send a message from here, say howdy, and of course, I can also say from this client. And but the only thing you can of course notice right now is there is actually no form of coordination between these two connected clients, simply because if you look at our the endpoint we are visiting at the moment, I'm going to collapse this guy. So if I go over here, let's go back to the chat service and then go to this one. So if you look here, really there's nothing happening. So what I'm actually doing, of course, this is a Pong. This happens, of course. So, but the only thing is I have this here. I'm not really doing anything with this message. I'm simply logging it. So what it means is that if we go to the terminal, we also should see this. So that's also what we have here. So, but this is actually not the interesting thing. So the interesting part I would like to show you would be this part. So this is slightly more robust, I would say, but again, I'll try to walk you through what is actually going on here. I would also connect you to some example projects on Actix Web as it pertains to working with WebSockets and building whatever it is you would want to. That would, of course, require some form of free time remitting of messages. So, but this also, of course, is adapted from one of the examples, but we would modify this, of course, to serve our own purpose. So, but anyways, this handler is actually, if you look here, is actually just taking in three requests. So one of is, of course, the actual request that's coming in. And now on top of that, we have a payload, which is going to represent the stream because once we establish a handshake within the client and the server, we would want to, of course, have a permanent communication, or more or less a coupling between both, so there can be easy transfer of communication. Of course, we don't want to constantly make a round trip just to get or send information. So that's why I would want to, of course, use WebSockets when we want to talk about at least the data communication layer at least. And now there is also again an implemented chat server. Again, I'm going to show you how this is implemented. But other than that, of course, you see here is also quite similar to all the endpoints we've defined before. So, but apart from that, the interesting thing is what you see over here, which is this Actix Web handler. So, but if we go over here, what actually happens is with every incoming request, we spawn off a new task and then we actually call this function. So again, this function is quite straightforward. It takes, of course, the chat server and of course the session and then the message stream. And then with this, of course, we now decide based on the content of the message. So we also get to decide, for example, if you look down here, we are looking at when it's just a ping or a pong. And other than that, the most interesting part for us, of course, would be when there is a text, which is the actual message, which happens when, of course, any of the clients sends a message. And this is taken care of when we, of course, when a client disconnects. So again, I take you this function again, which is also a very interesting one. So this is us actually looking through the message payload itself and deciding on what we would want to do. So here there are some additional flavors. Again, I'm going to point you to those examples on Actix, so you can also check them out for yourself. So, but it's here what we're doing is actually looking through the message itself, and actually decide if we have a command. So your user can actually add commands from the front end, from the client more or less, and then we decide on what we would want to do. And such scenarios could be when he sends a list, for example, or when he wants to join a new room, or when you want to, of course, get a name, of a room. But other than that, when we have an actual message that is not a command, then again we have this message handler here that takes care of it. And what it simply does is, of course, again, we've talked about working with channels in Rust, where we talked about the different kind of channels you could work with in Rust. Again, I'm going to leave a link in the description in case you don't or have no clue until now how to work with channels within the Rust ecosystem. So, but other than that, there is a defined enum of commands, possible commands that could happen. And as you can see here, we have connect, disconnect, list, join, and message, an actual message. So, but at this point, we have an actual message, and then we send a command for this particular enum. And that's really what we're doing. And then I can also show you what it's actually doing. So if I go here, um, so when we have a message, basically, the command is actually going to get to this point. And again, we have a list of rooms already. So we try to find the actual room that the user is trying to, of course, send message to, and then we send the actual message. So the function sending the actual message is actually just this one. So again, we passed through that's the sender that we create when we opened that channel communication using that one shot, because again, I'm going to leave a link in the description in case if you don't understand why we are even using one shot channel in the first place. But more or less what's happening now is, of course, we simply just loop through the users who need to actually receive this message, and then we send them a message. And that's really what we have right now, or more or less that's actually what this endpoint over here is doing until now. So again, what I'm going to do is, of course, take it to the browser. We're going to test this out, and then we're going to start making additions and making modifications, because again, I would also along the way show you how, of course, more or less get time to explain much clearer to you what each component of the code is doing, and we can again go ahead and make additional make some more additions, and of course make some improvements that we would like to see along the way. So I'm going to take you to the browser now, when we can test this out to see how things are looking, and then we can jump back right in here, and then we start actually writing some interesting code. So right here we are on the browser, and what I can do now is to try to connect with these two different clients like we did before. So I'll go to these different endpoints we have here, which is for V1, and I'm already connected. I'm just going to disconnect and then try to connect one more time, and then you see it also just gives me this message. And then I can also try to connect from this side, and then it also tells me there are two visitors. Now the nice thing, of course, is now I can send a message, and here it also shows you that this is actually being sent, but this is being received from this side. And then I can also do the same here, and then it's being sent out, and then it's received here. And so what I can also do now is to use some of the commands I showed you before. So now I can say list, and send the message, and then it's going to say main. And the reason is because I'm creating a default room called main, and then everybody's actually once you log in right now, you actually just push to this channel. So but what I can actually now do is I can go to a different room, and I can maybe call this dudes, and then I join. So what you see now here, it tells me I joined this room. And then to this other guy in this main room, it tells him that someone actually disconnected. And the nice thing now is if I send a new message, this one over here doesn't get this message anymore, because now it's no longer in this room, it's now in a different room. And but of course, if we want him to get the message, we can do like he did. We can again join dudes, for example. And then you see how it tells us like he has actually joined, and over here this guy is already there. So now we are told, oh, someone new actually joined. So now I can say hi dudes, for example, from here, and then he would get it. And I can say hello guy, something like this, and then he's also gonna get it. And then maybe, I don't know, I'm just gonna join another room called dev, and again the same thing is going to repeat itself. So this is actually how this setup is right now. Of course, the data is not being stored anywhere. So when you restart the server, of course, everything is lost, and then you have to start completely. So, but this, of course, is part of what I would like us to do, and we are again going to move as fast as possible. So, but to do that, I would like to introduce you to Torso. in case you've not heard of it before. So more or less, this actually offers you quite surprisingly an a SQLite database, but it promises to actually be like a production grade SQLite database that is actually supercharged with a lot of functionalities. It promises that you can actually do a lot of things, and so you get to create a number of course there is like a free plan, as you can also see from here, because you see this upgrade message here, which I'm probably not going to do anyways for now. So, but the point is that I wanted to, of course, test this out with this database just to also see how it works actually. And then, but the point is that you can actually use this to, work on some fun projects more or less. So, if also look at, say, Turso pricing, and you can of course already see what you can be offered. So right now this is actually where I am. So it's offers, like, as you can see here, 500 databases, 9 gigabyte of total storage, and 1 billion row reads, and unlimited embedded replica. So there is actually a lot this can be used for, especially if you are doing prototyping. But other than that, you actually can use it to do some more interesting works if you would want to. So again, of course, this is not like an ad more or less, but just something I wanted to, of course, throw it to you so you can maybe check it out if you have the time. So they also have let me see, quick starts. So you also, of course, have the option to use this in a couple of languages, as you can see here, TypeScript or JavaScript, Rust, like we are gonna do in this tutorial. Then there is, of course, Go, then Python, Kotlin, Swift, and the rest, whatever. So this is what I would be using actually in this application to do what I would more or less set the whole thing up, so we can, of course, see how things are gonna work out in the end. So that's it about Turso. Feel free to check it out. Yeah, so let's move back to our code. Again, I'm just going to stop these servers to get it out of the way so we can actually jump in and do some interesting work. So I'm going to move as fast as possible because, again, I think we've learned a lot in these tutorials that there would probably not be the need to spend so much time overflogging certain issues. So I'm going to move as fast as possible. I will try to clear out most of these files so we have like a clearer way to work, because I would have to create a lot of files in the process. I'm going to collapse all of this. And in here, I actually have a file already called DB. And if you remember, this was actually the file we had initially that we used more or less to work with the Postgres database. But what I'm going to do is in here, I'm actually going to create a new folder, and I can call this SQLite. So in here, I'm going to define all the functions that we would need more or less to interact with our database. So in here, I would add a few files. So I would need one for user, and I would need one for, I'm just going to call this rooms for now. And then in here, again, I'm going to add a mod rs file just to, again, I'm going to, in here, of course, bring this guy in into mod. So here I say pub mod and SQLite. And then in here now I can define pub mod rooms, and again pub mod um, users. So that's really what I want to do. And of course, apart from those, I would like to again create two models here. Those are going to represent my users and my, of course, the rooms as well. So again, I'm going to create two files here. I'm going to call this users, and I create another one and I'll call this rooms. Actually has to be singular actually. So I have to rename this to user, not users, because of course it should represent an entity. Okay, so I'm going to start with the users. It's going to be pretty fast and straightforward. Again, I'll have to bring those in here. So pub mod rooms, and again pub mod user. And then I'm going to, like I said, I will start with user to start doing the definitions. So for the user module, I have this defined already, and it's going to look something like this. There's not so much to it actually, so just the basic things we would need to define a user, really, that's it. And for the room, again, it's going to be quite similar. So I have this predefined already. Again, I need to bring these imports in. And that's more or less the basics of what I would like to have for those. So it needs to have all of this. So I would like a way, of course, to know who and who are in a room. As you can see over here, that's also why I'm using these members. Of course, I have these media URLs in case just in the future, for example, if we would want to send, say, images or whatever inside a chat, for example, this is one way we can actually do those. And the point is, if we want to accept file uploads, then what we can actually do is, when a user writes a message and provides a file, we can simply just put those files in, say, some blob store, and of course only append um, no, so this media URLs here, URIs here actually would be to, of course, define they would be specific to a room, and they can be changed, of course, but they could be a couple, maybe one, two, three, doesn't really matter. And the point would be like those images will actually be used to, say, kind of like notify like a room image or whatever, something like that. So you make on a room background or a room profile or whatever the case might be. That's really the point in here. But again, the same concept. We take the image, you put it in a blob store of some sort, and then we simply store those public URIs to those images, and then we can use those to render those images in the end. So that's really how I want this to look like. So let's proceed and make all the other definitions. So I'm just going to collapse the sky, and then we can move over to this our SQLite, and then start making definitions. We're going to start with the user. So here I'm going to simply define a mod. I'm going to call this mod users. So we can go through SQLite user, and maybe I can call it DB. So it's SQLite user DB, whatever. And then in here, I'm just going to define a couple of functions. So we'll have an async function. This would be our insert. So it should be able to take a user, which is going to be of type user model. We want to go through user, this one. So you should be able to take a user. Again, it's going to take a client. The client is going to be of type database. And the last thing, of course, we would want to take would be, I think that should be it actually. And then in the end, it's going to return two things. It's going to return a result. So within the results, for now, I'm going to say maybe return a U64. And actually what I need here would be a libsql. So I have to install this first, and then we can continue. So this should of course be from libsql. So again, when this is not the case, we can return an error. So that's the error, of course, has to be specific to this library. And so what we're going to do here is actually pretty straightforward. So what we can do is I can define a connection here. So the connection we can simply get from this client, and I can call the connect function, and then call the unwrap function, of course, to handle the what possible error we might have. And then other than that, I can simply call the execute function. And in here, I need to just provide an SQL, which should be, of course, a string. I can provide it this way. And then I also have the option to provide some params. So these params, I can provide them in a list like this. And then when we execute this, we again, because of what we get, because of the return type, we can simply await whatever it is we get out of this, and then that should take care of our return type. So this should, if everything goes well, we would of course get back like a U64. This is gonna of course show like this one. Of course, we can make if we successfully inserted into the database, but when that's not the case, we would get an error. So in here, I can fill in all these parts. I can say user.id, and I need to provide the rest, and then I'm just gonna pause and then type it all out. So I've gone ahead to actually fill in the code we actually need to write here. So it's actually pretty straightforward. We write a raw SQL query where we insert the values we got from here. And then I know maybe what you're already thinking, we're not doing any form of sanitization yet, but of course, the point you would be in, if you have followed us until now, the point would of course be to let you know that, or more or less call attention to those things, and of course make sure that you understand why they are in the first place. And so now you know, go ahead and of course sanitize the inputs before you actually make the insertion into the database, because it would be dangerous, for example, if you didn't. So apart from insert, I would like to add a few more methods here that's just going to help us to, let's say, get a particular user by the user ID, for example, or maybe get a user by email, or maybe get all users in the database, or also maybe even delete a user. So I'm just going to implement those as quickly as possible, and then we can, of course, proceed. So for get user by ID is going to be as simple as this. So again, we make a simple select query, and then where ID, of course, we provide the ID as a param. And then all we now have to do is, of course, to match the type of the data we are extracting from the row, and then we would be able to, of course, append this our user model over here. So we really need to explicitly, of course, cast the type of the data here, because otherwise this part would actually error out. And again, you also have the option to actually do something like or else, in case this is not set, but that I leave that to you, more or less. And again, for the other one, fetching the users by email is also going to be quite straightforward. The only difference is just going to be that we swap ID for email, and again, that's as simple as also what we have here. It's actually pretty straightforward. Then again, the next thing we would want to do maybe would be to get all the users in the database. Again, this is now quite similar to these other ones, but now of course we are using a while loop to read everything, every row that is returned basically. And the last but not the least, of course, would be to delete the user, which is a simple delete from the user table. So what it means is that we should have a table called users, and then we can of course perform all these operations on that user. It's really as simple as this. So this of course would be our user DB model. So what we can also do is to go ahead, of course, to the rooms and implement or something quite simple again for the rooms. So again, I'm going to call this pub mod rooms. This is already a room, and I can maybe call this again DB. And then in here, I'm going to again repeat most of the methods we already have for the users to keep this clean and easy to understand. So I'm going to, for a start, actually implement just one function, which is a function that's going to help us retrieve all the rooms in the database. And I'm going to leave out the rest for now, because again, I just want to show you how we can make this quite interesting, so we can integrate this with the chat server we have at the moment. So I have a function here for retrieving everything in the database. Again, I'm going to take care of this import. So I have lib database, and I have my personal room like this. And what else? I have some error over here regarding this two entries. And of course, I defined two functions that's going to help me map the values we get from, basically, if you remember, this has to be like a vector of strings. So I have these two functions defined up here. So this would basically help us to take care of getting the value back. So this should come from, I'm going to use it there this way. So this should, I have to do that one more time. So this should come from set JSON like this. And then of course this one should also come from here. So I can bring this in as well. And so that's basically it. So the functions are actually quite straightforward, as you can see. So the first thing we do when we want to do insert, or maybe I can also just show you a simple insert so you also understand what it could look like. So this would be a simple insert. And again, what we do basically is we take this slice of strings more or less, and then we convert it into a JSON string, and that's also what we store. And then when we want to retrieve this from the database, again, we do like the opposite to retrieve this value. So again, I'm just going to leave the rest out for you to implement, like to get a single room, delete a room or wherever. So, but why I really need this is I want to show you more or less what it could look like initially, because if we want to have like some predefined rooms, then we have to again not lose this each time we restart the server, so we can always easily retrieve this from the database and of course have this available no matter what the situation is without actually losing the data. So that's really the point. So let's proceed. So now what I can do is to go to the main file, and now what I would want to do is to maybe when the server is starting, I would like for us to be able to retrieve all the data from the data, all the rooms at least from the database, and then we can actually add this to the server here, and then we would have this each time we restart the server. So in down here, I can actually call SQLite. No, maybe I go to utils, or maybe I should already have something imported from utils. I don't. Okay, so I can say db get all this one, and that should be able to import what we need for us. Let's await this. And we seem to have, of course, we need to provide a client. So, but this is properly imported. Okay. So now we have to, of course, define a client, because again, if you remember in this definition, we have to pass this value in here. And what I would like to do again, if you remember in our app state, when we defined our app states over here, we actually had initially had this pool, which helped us, of course, to connect to our Postgres database. But now I want to switch this up for our SQLite database, and I'm just going to take out this pool in here and replace this, of course, with our connection for the to the actual database we need. So I'm going to take this one out, and I define a new one. I can call this DB client. So this is going to be of type database, of course, but I would like to wrap this within an arc, an atomic reference counter. So again, database from libsql. And okay, so now I can come back in here actually, and then I can replace this. So we have to now create this client, and then I would have to pass this client in here as well. And to do that, maybe to keep things as simple as possible, I'm going to come down here and create a function. It's going to be an async function, and I'm going to call it get client. It's not going to take anything, but it should be able to return database like this. And also in here, I need to define a couple of variables. So with the libsql, with the Turso SQLite database provider, you actually get, of course, your database URL and a token. You would need these two when you want to authenticate to the database. So I can put mine as mvars, and I can call this Turso DB token, something like this. Again, I unwrap, and then of course I get my URL. URL would be something quite similar than var, and then I can also call this Turso DB URL. Again, I come on, and then I unwrap as well. So if I have these two values, more or less the token and the URL, I will now need to call the builder this builder method more or less from from the Turso client, and then I call the new remote because again you have the options to do a new local replica and also remote replica, but I would like to connect directly to the remote database. And then I pass the two important arguments, of course, the URL and the token. And then when I've passed that, of course, it's implemented again using the builder pattern. I can say build and I await and I unwrap. Come on. And now this should be able to return our client for us. So now what I can simply do is to come up here and define a variable, and I call this client would be this. And again, I await what's going on. And I await this more or less. I have to close this up. So now we have our clients, and of course here I need to pass this as a border more or less. And then in here, what I need to now pass, I can simply pass this as, or maybe I can actually name this so I don't have to create a new variable. I can call this DB client, and then I pass it here by reference, and I simply replace this with this. And that's actually all I would need to do in here. Of course, this is this should be, as you can also see here, this should actually have been the type. So maybe what I can already do is to, instead of doing this, I'm gonna take this out and I say arc and I call the new method, and then I simply pass this in. And now we have our database, and then now it should also satisfy the requirements here. The only difference now is that we also have to make the modification for our test case, and that's also fine. I'm probably just going to copy all of this again. I'm just going to copy this to make it quite interesting, and then we can fix this later. It doesn't really matter. And now I copy this and replace it with this, and this should be fixed. I'll collapse this again. I'm not sure if this still going to work, the test, but again, we would have to test this out later. And then we seem to have some problems here. And then this would be, of course, some of our methods that still rely on the pool. And maybe I don't want to actually make these changes now. So again, I'm going to copy this, maybe bring back the old guy, and maybe also add it in here as well. So I say database, and again arc, this one. And then what it means now is I have to come in here and then maybe add poll again. And then I also have to fix the test as well, because I always have to do this. So, but that's fine. And because again, I don't want it to break some of the things we already did in the past. So, but that's okay. So, but the really cool thing we want to do is to, with this client over here, we want to be able to, of course, retrieve the rooms. So now I can actually say, let's rooms. And the point is that I would like us to get back the rooms. If not, we can actually just start up with some base vector of empty string, something like this, or empty vector more or less. So I would like to match this example, and then I can say, so if we actually have a value, if we have some rooms, then we simply return those rooms actually. So, but if none, I'm simply going to return a vector, an empty vector more or less. Okay, so now we have our vector of rooms. And now what I would like to do is to, if you go to this new function here, we actually are just using like a hash map of rooms. But what I would like us to do now is, of course, replace this with our own room, that's going to represent an actual room. And then we make the modification down along the line and then see what errors pop up and then try to fix them along the way. So in here, I'm going to add rooms. Again, like we said, is going to be a vector of our personal rooms. And then all we have to now do, of course, is to add the new ones we created in here, and that's already fine. So with this addition, our server now has, of course, access to the rooms. Oh my God. I also have to come down here and again pass the rooms. If we actually had one, oh my God. Okay. I'm gonna come up here. If I can find out where I made the definition, this one. And then I come beside the DB clients. I'm gonna replace this with this. And it seems I'm doing things the other way around. At some point, I'm just going to comment out this test because it's not going to keep drawing us back. Okay, so let's come back here. So now we actually now have access to these rooms. And now what we have to do would be to actually try to use them. So now we go to our definition of this chat server, and then over here you can actually see where we defined the rooms. Again, we're gonna make small changes. I'm gonna remove this for now. Again, replace this with our personal rooms like this. And now we should get some error here, which is also fine. So what it means now, we will no longer need this one. Again, if you see here, this is also where we were initially appending this main. That's, we always had this one as a starting point. So again, I'm going to remove this, and then this would of course replace this one. Okay, so now we have our rooms here, we have our chat server implemented, but the only issue now is, of course, all the methods in here have completely broken down. And what it means is that we have to painstakingly go through each and every one of them to update them with the changes we just brought in. And again, it's not going to take so much time. We would do all of that together. So let's actually proceed.